Alright, okay, let's go on with this example. Find the vector, the parametric and Cartesian equation of the line passing through a given point and parallel to the line, right? So parallel to the line, okay, then let's have some representation, diagram. So you have a line and they said that find the equation of this line, and this line is passing through the point, right? It's passing through the point 4, -5, -1. Means that I can say that this is a fixed point, right? It's a point on the straight line. So according to, by using the formula, we have R equals to A plus TV. As we already know the value of A, right? The vector A. So which is 4, -5, -1. Or I can rewrite the coordinate here into a vector, right? It's a position vector. 4i minus 5j -k. Or I can just write in a column vector form 4, -5 and -1, right? And later on, we already have the information for A. The most important, we must know a fixed point. And secondly, we also must know the direction vector. But can you try to think, where is the direction of this line? This question is not directly giving you the direction of the line, but they are telling you something. And this line is passing through this point and parallel to the line. This is another line, right? It's another line. So it means that there is another line parallel. So these two lines are parallel, or we can say that these two lines are actually in the same direction, right? Means that the direction vector of this line can be used as a direction vector for this line because they have the same direction, alright? Same direction, or we said the most proper word would be they are parallel, alright? We can use the direction vector from this line. So this line is in the form of Cartesian, right? It's a form of Cartesian. From this Cartesian equation, we can rewrite it into a vector form. We can rewrite this back into the vector form to get the direction vector. So means I can actually rewrite x minus 2 over 3 to be in terms of t. Alright, this whole thing equate to t. I can say that I can write y plus 3 over 4 equals to z minus 1 over 1 equals to t. From the Cartesian equation, I want to convert to become a parametric form. So I equate this everything to a t, alright, as they are the same. So I can say that x minus 2 over 3 is t. Y plus 3 over 4 is also t. Z minus 1 over 1 is also t. So as I can rewrite this as a subject, so I have 3t, 2 plus 3t, 2 plus 3t, and y will be 4t plus 3, -3 plus 4t, and z to be 1 plus t. Alright, then you have right from Cartesian form, right? Cartesian form into parametric form. Alright, into parametric form. So, and you also can rewrite this into a vector form. As you know that x, y, z is any point, right? Is any point on the straight line. X, y, z. I can rewrite this to be a position vector of a point, any point. So, and here you have 2, the constant, the one that independent from t is 2, -3, and 1, right? Plus with t. This is the direction of the line, all right? The one that the coefficient, right, with the t, or the coefficient, the x component, the y component, and the z component, right? 3, 4, 1 multiply t. So if I rewrite back, this will be 2i minus 3j plus with k plus with t, 3i plus 4j plus with k. The most important thing here will be this one. Okay, will be this. Because according to the formula, this is a direction vector, right? It's a direction vector. So means that this line, this is the vector equation for this line, right? From this line, I have become the vector equation. So it means that this line having the direction vector of this line will be 3, 4, 1. 3i 4j plus 1k. Alright? Or we can rewrite to be 3, 4, 1. So, what's so important about this direction? Because this line is parallel, passing through this point and parallel to the line of this line, right? So it means I can take the v as the direction vector for this line. Alright? Okay, let's see how to find the equation. Alright, now very simple. You want to find the equation of this line, as you know that there is a point and you know that this line is parallel to this line, another line, and you have convert this into a vector equation, and you get from the vector equation you get the direction of the line, and this direction of line of course will be the direction of this line also, because they are parallel. So now again we apply the formula R equals to A plus with TV, right? So again, so your R will be A, your A will be, okay, I can straight away write in this form, -5, -1, A, right? 4, -5, -1, plus with T, the direction of the line is the same with this line, the direction and this direction will be the same. So I will getting 3, 4, 1. Okay, but I no longer using T, alright? I can using another parameter, alright? As just now I have using T for represent this, right? Yes or not? So a proper way of writing here will be I will using another parameter. Okay, usually we can using T S lambda, alright? Usually we're using these three. So or gamma, alright? Either one is okay. So just now I'm using T in my working. So now I'm using lambda for this line, alright? To denote another straight line, alright? So lambda. So and I have alright, my vector equation here will be 4i minus 5j minus k plus with lambda 3i plus 4j plus k. I'm writing this because it's easy for me later to writing in parametric form. So x, y, z, right? Why x, y, z? Because R can be any point, right? Can be any point on the straight line. So I can say that x to be 4 plus 3 lambda, right? 4 plus 3 lambda, and y to be -5 plus 4 lambda, -5 plus 4 lambda, and z in term of lambda will be -1 plus lambda, right? -1 plus lambda. This is vector form, right? Vector form. And this is parametric form. So finally, you can rewrite this in Cartesian form, right? In Cartesian form. So you making all the parameter become a subject, right? Become a subject. So as from here, you know that lambda can rewrite to be x minus 4 over with 3, right? Followed by lambda will be y plus 5 over with 4, right? And for this, lambda will be z plus 1. So since all this is lambda and I want to eliminate the lambda, so I just compare these three and conclude that x -4 over with 3 is the same as y plus 5 over 4 and equals to z plus 1. So this is the Cartesian equation, right? Cartesian equation of the required straight line. So hope you understand this question. So okay, let's go for more example in the next video.